So how does the ocean respond to that? The ocean responds to wind stress in terms of Ekman transports. Okay, you have a wind stress, you get Ekman layers. Okay, so the Ekman transport is perpendicular to the wind direction, and the magnitude of the transport is proportional to the wind stress. So let's have a look how that looks like over the Southern Ocean. And there's a little sketch here. Okay, there's a sketch here on the left. I show with the mouse here. You have the westerlies, and there are the strongest in some regions, say around 50 degrees south, a little bit north of that. And then as you go north, the wind stress magnitude decreases, the direction stays the same. But as you move to the south, also the magnitude decreases. So this is how the wind stress field looks like if you look from above. And now you can draw your Ekman transport. Okay, you can add these red arrows. Okay, you can see here the red arrows are Ekman transport. The biggest Ekman transport you get where the wind stress is the strongest. Okay, and it's a transport that goes to the left, which means to the north. Okay. All right, and then you look at it, and then you can actually see that you create a convergence north of the center of the westerlies. Here you get a convergence, which means if you put a control volume into that area, there's more water coming in from the south than leaving in the north. And this is what we call a convergence. And what happens in this situation is there is a downwelling, a downward pumping of surface water induced by the wind into the ocean interior. Here on the other side, you get a divergence, means there is water actually moving out of a control volume. Okay. This is called the divergence, and it actually leads to upwelling. It triggers to upwelling. And in these areas, the effect is so strong that you actually upwell water from more than 3,000 meters and bring it up to the surface. So here are some maps, some other maps. So in case you're confused about this, some other maps for the Southern Ocean, where from the wind stress we actually can calculate the wind stress curve. Okay, so while it might be a little bit confusing here, the most important thing is that you can see a zero line. Okay, can you see the zero line? Here, look at the leftmost figure. This is the annual mean. You can see a zero line. And these are contours. What a contour means that it's negative here on one side and positive on the other side. So the zero line separates a region of positive wind stress curve from a region of negative wind stress. So on one side you get downwelling, and on the other side you get upwelling. And then you can look at over the year, there are some variations, or so some movement of where this region is. Okay, it depends on in which ocean you are essentially, but it operates year round, this mechanism. And what it does is actually quite spectacular and will be shown on the next slides.